we're going to go over exponents to start, okay? We'll just go over a couple of examples. So the first example is if we have a number, is how to represent it as an exponent. So say we had 5 times 5 times 5 times 5, okay? And they wanted us to represent this as an exponent. Okay. An exponent is two things. First, there's a base number. Okay, that's called the base. And the second thing is an exponent. Okay. So the base number will always be the number you're multiplying by. Okay? So in this case, what number are we multiplying by?
5.
Yeah. So that will be our base number. So we have 5. Our exponent is the number of times you multiply the base number. So how many times are we multiplying 5?
4 times.
1, 2, 3, 4. So our exponent is 4. So essentially our number is 5 to the power of 4. Does this make sense? Okay. And if we were to reverse it, say we had 6 to the power of 3, and they wanted us to expand it, how would I represent this?
You're going to multiply 6 3 times.
Yeah, so we take the base, and we're going to multiply the base 3 times, because 3 is our exponent. So we end up with 6 times 6 times 6. Okay, does that make sense so far?
Yeah.
Okay, so you had a tougher question. Let's go over and take a look at it. Okay, so question 14, they're talking about, first off, they're talking about powers of 2. So in other words, we're looking for our base is 2, and we got to figure out the power, or the exponent. Okay. Now it asks us how many numbers can be between 100 and 200, or how many numbers between 100 and 200 can be expressed as powers of 2. So your steps as follows. So what we're going to do is we're going to trial and error this. Okay. So let's go through our very first one. What would 2 to the power of 1 be?
Just 2.
Yeah, that's right. It's just 2. We just represent it once. If we have 2 to the power of 2, 2.
4.
That's right. We do 2 times 2, and that equals
4.
Good. 2 to the power of 3.
8.
2 times 2 times 2. 2 to the 4.
16.
Yes.
Okay.
Always just take from the previous power. We're just multiplying this number by our base again, right?
Okay.
So if you noticed, here was our base, and then because we're multiplying by 2, I multiplied that number by 2, I got 4. Our base is 2, I multiply 4 by 2, I got 8. So if I got to find our next number up in the powers, I multiply 8 by what?
2.
What would I get?
16.
Good. And it's going to start to move up quickly. Okay, I'm going to stop writing in the middle part. Do you guys understand the middle stuff?
Yeah.
So 2 power of 5. Okay, we know that we'd have to write the number 5 times here. What would our next number be? What would I have to do to 16?
You have to multiply by 2.
Yeah, multiply by 2. What would I end up at?
32.
Good. Let's keep going. 2 to the power of 6. Got all our stuff in the middle.
64.
That's right. We multiply 32 by 2. You get 64. Have you even reached 100 yet? No. So none of these powers so far, because remember what we're trying to do. We're looking for powers of 2 that are between 100 and 200. So we haven't even found a power of 2 over 100. Okay? All right, let's look for our next one. 6 to the power of 7.
Yes.
One's a little harder. You want to use a calculator? You want to write it out.
Is it
128. Okay, 128. Is that between 100 and 200?
Yeah.
Okay, so we know we got one answer. Let's underline it in green. Now, according to our trick here, 2 to the power of 8, what would I do to get the next power?
You have to multiply by 2.
Okay, what would I end up at?
If you had another digit, does it come up?
What's going on with this? Oh, your calculator's a little Still there? Oh. Now try. So when you multiply 128 by 2, what did you get? 256. Is that between 100 and 200? No. So how many powers of 2 are between 100 and 200? Just one. That is the only power of 2 between 100 and 200. So, the question asks how many numbers between 100 and 200 can be expressed as powers of 2. These are all our steps. We worked them all out. We knew we just had to multiply by 2. Only one. So our answer is only one power of 2 is between 100 and 200. Okay? And it is, what's the power of 2?
2 to the power of 7.
That's right, it's 2 to the power of 7, which equals what?
256. No, wait.
There you go.
128.
That's all right. Good. Now, here's another one. Which power of 2 is closest to 1,000? Okay, so which power of 2 is closest to 1,000? Now, I could start at 2 to the power of 1 again, 2 to the power of 2, but have I done that already?
Yeah.
How high did I get?
You went up to 2 to the power of 7. No, 8.
We even went higher, actually.
I think we went up to 8.
Let's go look at our old work.
Okay.
And what was the number it was equal to?
256.
Okay, so let's start there, because we know we're much closer to 1,000.
Yeah.
So let's go back. We'll start with that information. So we knew 2 to the power of 8 was equal to 256. So same rule before.
Yeah.
2 to the power of 9. What would I do? I'd multiply it by
2.
Yeah.
That is 512.
Hey, there we go. All right, let's keep going. 2 to the power of 10.
1024.
Hey. Do you want to go a little farther? See if the next one will be closer to 1,000?
No.
No?
Over.
For sure, right? Because this one's already over, right?
Yeah.
If we multiply that by 2, it's going to be much farther from 1,000.
Yeah.
So which exponent is closest to 1,000?
The 2 to the power of 10.
Yeah, so we can just write it up here. We know that 2 to the power of 10 is equal to, whoops, not 2. It's equal to 1,024, right? This was our answer here. Does that make sense?
Yeah.
Great. Okay, number 16 talks about there's a man going to Halifax, okay? So
Yeah.
I'm going to draw a little picture of this. It always helps if you draw a picture. So here's our man, right? He's going to Halifax. And he had 7 sacks, okay? So that means, let's say here's, we'll draw his sacks, there'll be circles, okay? So there's 1, 2, 3, 4, 5, 6, 7. Those are his 7 sacks, okay? So 1, 2, 3, 4, 5, 6, 7. Wow, that is a lot, eh? And then in every sack, 7 cats, okay? So we're going to use little shapes to represent cats. What shape would you like to use to represent a cat? Star?
Yeah.
Okay. So in the sack he had 7 cats. Okay, so each of these was 1, 2, 3, 4, 5, 6, 7. And that repeats over and over again. That's quite a bit, eh?
Yeah.
Let's see, I'll copy and paste this. For each sack. Okay, so that's getting pretty confusing already. Alright, we're getting lots of numbers. So let's actually talk about how we can already figure out how many cats. So the first question says, how many cats were there? Show your work using powers. Okay, so what do you think our power is going to be? Have you noticed what the base number is in this question?
7.
Yeah, the base is going to be 7. So before we even go farther in this question, let's start working with how many cats there are. So he had 7 what to start with?
You have 7 sacks.
Okay, so how would you represent that as a base of 7? 7 to what power to represent sacs?
Would it be 7? 7?
It's going to equal 7, so what exponent will we have there?
Oh, 1.
1, right? That's the first set of things he had. He had sacs, right? 7 to the power of 1. Now, in each of those sacs, there's 7 cats. So what do you think that will be? That will be 7 to the power of what? Okay. Think of it like this. It's the next set of 7s. So in each of those 7 things, there's 7 more things.
So would it be 7 to the power of 2?
That's right. It's our next set, right? So we have 7 to the power of 2. Now we've got to figure out what that is. So in order to find that, we take our old answer and multiply by what?
By 7.
Yeah, we multiply by our base. So how many cats is this man going to have?
49.
Very good. So he has 49 cats. You already figured it out. I could go about counting them, but here's another way to think of it. There are 7, 7, 7, 7, 7, 7, 7. So each of these is 7, and there's 1, 2, 4, 5, 6, 7. 7 times 7, which makes sense. 7 to the power of 2. And finally, the next part of the riddle. So that was question B. Sorry, that was A. We knew that he has 49 cats. So we'll write that down, 49 cats. And each of these cats had another 7 kittens. Okay? So that's our third set of 7. So how would we represent that as a power?
Would it be 73?
Yeah, it's just the next set of 7, right? So 7 to the power of 3. We're going to have to figure this one out. Multiply 49 by what?
7.
Yeah.
343.
343. 343 kittens. Okay? 343 kittens this man had. Now, this is the tough part. The actual riddle says how many were going to Halifax. So we got to figure out how many things are going to Halifax. Well, first off, there's how many kittens. This is going to be our part C. This is where we answer the riddle, okay? So how many going to Halifax? Okay. So first of all, there's how many kittens?
343.
Okay, so kittens, 343. What else is going to Halifax?
The cats.
Cats. How many of those?
49.
Anything else going to Halifax?
The sacs.
Sacs. Are sacs considered people or living things?
Is it big?
Yeah, a sack is just a bag. So we probably don't have to include how many sacks are going, but we can in our second answer. This will be how many, we'll say, living things, okay? So this will be living things. And our second part will be things in general, all right? So just things all together. So we know, again, we'll repeat it. Kittens is 343, plus our cats for 49. Plus in this one, he's taken his sacks, so how many sacks?
7.
Okay. Anything else going to Halifax? What's the very first line say?
He's going.
So how many more are going to Halifax?
1.
1 man. Plus the 1 man's going to Halifax, right? Okay. Oh, that's not a 1. So let's figure out how many living things and then how many things in general are going to Halifax. Yeah, 393. What about on the other one? It's going to be 400 because if you think about it, we have the same numbers here, okay? The only thing we're adding is what? Oh, you forgot the 1. The only thing we're adding is 7. So if I do 7 plus 393, I'll end up with 400. So 400 things are going and 393 living.